All right, so once you've been through the exploration, we're going to kind of pull it all together. So we noted in the last video and at the beginning of our exploration that the parent function for an absolute value function is just y is equal to the absolute value of x. And we noticed that its graph sat at 0, 0, its vertex was there, and then its slope was 1. So if we go over 1, up 1 in each direction, we could graph what we call the parent function of our absolute value function. Then we made some transformations, and every time we added something to the function, or we added or subtracted on the inside, or we included a value out front, it transformed or changed the function. So we're going to pull it all together based off of what we noticed there. So let's start with this k value. Anytime you add or subtract something to the end of a function, okay, particularly this absolute value function, your graph is moving in a vertical direction. So this one right here is a vertical shift. Okay, now if we're adding a k value, then we're shifting up. If we're subtracting a k value on the end, then we're going to shift down. So essentially, that k value is transforming it just by moving it up or down. And again, it's moving the whole graph. So it's taking that vertex and moving it to a different point vertically. The h, so this h value, is moving it horizontally. So this is a horizontal shift. Okay, meaning left and right. Now this is the one that we noticed was backwards. So again, if you see a negative h inside of there, this one actually shifted it right. And if you see a positive h inside of your function, then it shifted left. And then lastly, the a value affected the slope when we graphed. So these are linear pieces, so they're related to that a value. One thing that we noticed is when a was bigger than 1, so I'm going to use the absolute value, meaning if the absolute value of a is bigger than 1, so say we have a 2 out front here, or we have a 3 or something that's larger than 1, it's actually stretching that slope, it's increasing it. So we call this, oh, I'm not sure what happened there, a vertical stretch. Okay, and if it's a fraction value, so the absolute value of a lies between 0 and 1, maybe I'll make those look like a 1, then we have what we call a vertical shrink. Okay, and it's either stretching or shrinking by whatever the a value is. So we use that a value to denote the scale factor by which it's growing or shrinking. And then lastly, just remember if there's a negative out front of that a, so if we have a negative a, then we're looking at a reflection. And the reflection is not over the x-axis necessarily or over the y-axis, but it's a reflection over the vertex, meaning that this one is going to open down. And that's what we're going to say at this point. So it would have a v that is opening down instead of up. Okay, so again, that a value, either it's a stretch, it's making it very tall and skinny, or it's a shrink, meaning it's making it super wide, or it is flipping it over so that the v is opening down. So we like to look for that negative. And again, it doesn't matter if there's negatives in other spots in the function, but that negative out front with the a will flip it over. So let's go through a few of these examples and just use these transformations to see if we can graph these functions. And we're going to practice a few of the key features as we go. So again, looking at this first one, we're going to pull it apart piece by piece. So the first thing is this negative. Now we said if the negative is out front of the absolute value sign, that means there's a reflection. And for now, we're just going to state that there's a reflection. There are different types of reflection, but for now, again, reflection, flipping it over. If you want to write opens down, something that helps you remember that. And then we look at the next piece. Notice this 7. The 7 is stretching, right? That's greater than 1, so it's increasing that slope. So we're going to say and stretched by 7. Okay, so when we jump down here, notice the vertex didn't move anywhere. So we're going to still be here. It didn't shift at all, but it is going to open down and have a slope of 7. And if you want to think about that as like 7 over 1, that's your rise over run. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, and then I'm going to move to the right 1 and put a point, or down 7 and to the left, because remember these create a V and they're symmetric. And then do the best you can to connect those with straight lines. Again, if you look at our diagram, the vertex is there at 0, 0. The domain on this, the arrows are going in both direction, right? We talked about domain on these functions. Any value works. So we say negative infinity to infinity, the smallest value to the biggest value you could think of. Or if you want to write it, and you can just choose one of these ways, but you can say all real numbers as well. The range, if we're looking at the range, again, we kind of are looking at vertical lines and we're figuring out where our function is, and it looks to me like it stays below this value, right? And that's where y is equal to 0. So we are going to write as our range that it comes from negative infinity or any number smaller than 0 up to 0, and we include 0, so we use that bracket. Or if you want to use the inequality notation, you could say y is always less than or equal to 0. Okay. Again, I'm going to try a couple more of these. So if we look over here at g of x on the right, we notice that this is just adding 6. Now notice that is going to be the k value. It's outside of the parentheses. So if we look back up here, this is the k value, and the k value shifts this vertically. So this is going to go up 6. So we are going to say shifts up 6. So down here on our graph, we are going to go up 1, 2, 3, 4, 5, 6 from the origin, because the parent function sits at the origin. This one's been shifted up 6. And notice that the slope out here is not anything greater than 1. So if there's nothing written there, we know that the slope is 1. So we go over 1, up 1, over 1, up 1, and we do it in both directions to finish creating our V. Okay. So notice again, if we identify the vertex, it went up 6, so it's at the point 0, 6. Domain again, always negative infinity to infinity for this function. And again, if we're looking at the range, notice here the graph is not down here at all. So the graph doesn't start until y is equal to 6, and then it looks like it always stays above 6. So we are going to say from 6 to infinity, include that value of 6. Or again, if you like to use the inequality notation, y is always greater than or equal to not 0 but 6. All right, let's do one more on this page. Here on the left, again, you'll notice that this value is subtracted on the end, so it's not inside the parentheses, not like the one you see over here to the right. That means that this is the k value. It's a vertical change, so that's going down 3. And then you'll notice this right here is 3/4. That's going to shrink our slope because it's less than 1. So we're going to say a vertical shrink. That doesn't say vertical, but it's a good try. A vertical shrink by 3/4. And, right, shift down 3. So on our graph, we are just going to go down 3 and we're going to put a point. We know it's going to shift down 3. And then that 3/4 is going to act like our slope. So we are going to rise 3 and we are going to run 4. Again, it's not a negative 3/4, so it's not opening down. So we know that this V is going to open up. And we use that slope of 3/4 to plot those points. Again, then just identify your vertex. So we went down 3, still on that y-axis. Again, the domain is remaining the same. And our range, again, we're looking at y values. So again, the graph is not down here at all. The graph here stays above this -3 line. So we are going to say from -3 up to infinity. Okay. I'm going to skip over the next one, and we're going to look at one more of these. So let's look at h of x here. I'm going to just pull this apart again. So notice this -3, just like the last one, we're going to go down 3. This negative out front means that the graph will open down. We call that the reflection. And then this 2 right here is going to stretch that slope, or double the slope. So we're going to say all of those ones. So we're going to say there's a reflection, shifted down 3, and stretched by 2. Now I'm being very vague. I just want us to understand kind of the main idea related to these. We haven't covered the other reflections or horizontal shifts, so just these basic ones. So again, we're going to start by going down 3, and we're going to put our vertex right there. It didn't move left or right at all. From there, we know that it's going to be reflected and stretched by 2. So I'm going to start counting my slope down, and notice your slope there is like 2 over 1. So I'm going to go down 2 over 1, down 2 over 1, and do the same thing in the left direction, creating a slope of 2 for my graph. Okay, again, you can identify your vertex there. Our domain remains the same, -infinity to infinity. And then notice your range, your graph does exist down here. So in this case, the graph never goes above -3. So we're going to say from -infinity to -3. Right? Or you could say again, y is less than or equal to -3. Be very careful that you do not create an inequality. I know it looks like you're saying, well, -3 down forever, but we always go least to greatest. So we would never, ever, ever put the -infinity on the right side, because that's the smallest value you could think of. It's not a value in and of itself, but the smallest value you could think of. So we always do -infinity first, and then up to the value we're looking at. Really quickly, we can identify the vertex using these transformations. So remember that equation that we looked at on the front there, vertex form, looked like this. And we talked about this moves things vertically, this moves things horizontally. So when we want to identify the vertex, really we're just saying, well, where did it go? Well, it went to our H and our K, right? That went horizontally and vertically. And I'm going to put a negative in there just because it seems to help you guys understand that we're talking, whenever we pull that out, we're talking about the opposite. So it's not always negative, but the opposite of what you see inside the function itself. So jumping down here, if this on part A right here is my H and my K, then if I'm identifying the vertex of this function t of x, I am going to say, well, I'm going to do the opposite of h, so if that's a -2, it must be going to the right 2, and it must be going up 7. So if I'm going to graph this function, I know that the vertex is at 2, 7. If I jump down to B and identify the vertex here, again, here's my h and my k. We do the opposite of h, so if that's a +1, I use a -1, and the k value is 10. Okay, and again, we can do the same thing over here. So our h and our k, again, do the opposite of h. So I'm going to use a +3. The k keeps its same sign. And then for D, if there's not an h value, remember that would just be 0, right? The h value is 0 while the k value is 4. Lastly, the domain and range. So describe how it can be used to identify. One thing I want you to recognize is that the domain on this function is always all real numbers, or in other words, -infinity to infinity. This is going to be our domain no matter what the function looks like, okay? Then to find the range, it can be one of two things. So the range is either starting at the k value and going up to infinity, and we always use that bracket on the k value, or the range is below a certain value, so it's coming or includes all this really small values up to the k value. Okay, so one of those two. So how do we tell which one? Well, if it's k and then everything bigger, that's when our v is opening up. So it's k to infinity when our a value, so our a is positive or greater than 0. And when a is negative, right? Then our graph is opening down, and so it's coming from negative infinity. So we can tell based off of that. So jumping down to these examples, if I'm looking at example A, again, the domain should not trick us. We know that any x value can be plugged in here, and a real value will be created. That would be the same for all of these. So anytime you're asked for the domain, and it's an absolute value function with no restrictions, then we're looking at a domain of negative infinity to infinity. Okay. The range, however, again, is related to the k value. So remember, this is the y value on the end of each of these, and the y value is the only thing that relates to the range in this. So we look at this and we say, well, first of all, is it opening up or down? So I look right out front here to see if there's a negative. Remember, only that negative opens it up or down. There's no negative, so I know this one's opening up. So it's going to start at my k value and go up forever. So the k value is 2, and we're going to go up to infinity. Again, if I jump down to B and I'm finding the range here, I look out front to see if there's a negative right here. There is no negative, so that means this guy's opening up. So the range starts at the k value of -6 and it goes up to infinity. Again, if you like writing them as inequalities, you totally can. It can be y is greater than or equal to -6, not a big deal. And again, on all of these, I don't think I gave you a negative example. That's my bad. The range is going to go from the k value up to infinity because there is no negatives on the front here. Just know if there was a negative there, so if this is negative, that's when we're going to say, okay, well, this time it's coming from negative infinity and going up to -2. But because there is no negative, again, we're going from -2 up to infinity. Okay. And essentially, hopefully you can connect these absolute value functions with the linear function. The slope works in a very similar way, which I hope we understand. So if here's our absolute value function, this is the linear function that we were used to in the past. This right here represented the slope, right? This also relates to the slope of your v. So both of these things have a slope. And the v, we just remember it's always creating a v, so one has a positive slope on the side and one has a negative slope, but it's all related to that slope. Definitely a big difference is that these have a vertex, right? This has a vertex where our linear equations continue to increase or decrease without switching. So practice identifying where is the vertex, because again, that's the biggest difference. So using that HK, and then we use the slope to help us graph our V function.